Hello everyone and welcome to the Data and Database lecture. I am Hossein Mohit and in this session we are going to cover some basic concepts in data management, like what data is and what a database is, how databases are structured, and some key terms related to the database and data management. Just a quick note that you need to know that listening to this lecture alone is not enough for being successful in your quizzes and assignment. This is just a brief overview. So to be really succeed in this lecture and in this course, you will need to dive into the textbook and study the material in detail. Data and databases are the core of the managing information. Think of a data as a building blocks of information. It's a basic unit that, when presented in a useful way, it becomes what we call it information. On its own, data doesn't mean much. It needs context and proper presentation. A database is simply a technology that stores data. When we talk about the databases today, we usually think of the computerized systems. But even something as simple as a notebook or a ledger is a type of database because it records and keeps data. In fact, humans have been using databases in some form for a very long time, ever since we learned how to write things down and keep records. In recent years, databases have become an essential part of our daily lives. Every time you log into your favorite app or social network such as Facebook, you're interacting with a database. That social network itself is built on a database, which you will learn more about later in this course. Even something as simple as a phone book is a database, whether it's the old paper phone books, which your grandparents used to keep by their phones, or the contact list on your smartphone today. These are all examples of the databases. Databases allow us to turn data into useful information to help you understand the relationship between data, databases, and businesses. Let me give you an example. So, data is like a blood in a business. The database is like the circulatory system that keeps this blood flowing. Just as blood is essential for life, databases are also essential for the daily operation of the businesses. In the past, businesses relied on simple ledgers to keep track of data, but today is different. Today, we need functional computerized databases to manage all these data effectively. So think of a database as the heart and vessel of a business. Without a good database, a business can't survive. Just like you can't live without blood and the systems that keeps it flowing in your body. This course is important because in today's world, a successful business needs a strong and reliable database system. Now let's dive into the structure of a database. Every database has something called a schema. Think of a schema as a blueprint that defines how the database is organized, how the data is stored, and in what format it is stored. In this course, we will focus specifically on relational databases, which are the most common type used in businesses of all sizes. In a relational database, there are three main concepts that you need to know. The first one, table. These are also known as relations, entities, or classes, depending on the context. If we are talking about the mathematical logic behind the databases, we call them relations. If we are discussing the design of the database schema, we refer them as a classes or entities. And when we are working with an active databases, we usually just call them tables. But no matter of the term, they will all refer to the same idea, which is a table. A table is organized in a grid format with columns and rows. Each table is centered around a specific entity, like an employee, customer, or product. For instance, an employee table would contain data related to the employees. Most databases will have many different tables. The second one, attributes. These are all the columns within the tables. Attributes are also known as variables, characteristics, or features. For example, in an employee table, employee name is an attribute. In a product table, product description is an attribute. The number and type of attribute in a table depend on what the table is about and the context in which is being used. For example, a customer table for a local restaurant might not need to include social security numbers. But if you are designing a database for a medical office, social security numbers would be an essential attribute. The third one, records. These are all the rows in each table. Records are also called tuples in the context of the logical mathematical design, and they can also be referred to as rows, examples, or observations. Each record represents one place of information. For example, a row in an employee table would contain all of the related to one employee, and a row in a product table would contain all the data related to one product. So let's look at the example of the table, which also known as a relation, entity, or class. In this example, you can see that the column represents the attributes. These are things like employee name or employee ID. Typically, the name of these attributes are stored in the first row at the top of each column. The rows, also called records or tuples, represent individual entries. In this case, each row corresponds to the one employee in the employee table. In the relational databases and design, we also have something called an entity relationship diagram. This diagram describes the database's schema. It shows you the tables or entities that exist when the databases and relationships between them. You will learn how to read and create this relationship diagram in later chapters. For example, in the diagram generated by Microsoft Access, you can see 5 tables: retail, order, order item, warehouse, and inventory. The diagram shows the attributes of these tables, but it doesn't display the rows or tuples. Entity relationship diagram only include the table names, attributes, and the relationship between tables. They also indicate if an attribute has a specific role, such as being a primary key or a foreign key, which we will learn about it later. Entity relationship diagrams are the final step in the design before you create a data schema using a database management system. By the way, when we refer to a database, we are often talking about the database management system, or DBMS in short. Database management systems, or databases for short, can have different orientations. In this course, we focus on an orientation which we called it OLTP, or Online Transaction Processing Databases. OLTP databases are typically relational databases used for day-to-day business processes. They handle daily transactions and highly structured and normalized. These databases use standard SQL for querying and manipulating data. OLTP systems frequently insert and update data, often modifying it, and all intentionally kept small to ensure fast transactions. On the other hand, we also have OALAP, or Online Analytical Processing Databases. OALAP databases are designed for analytical purposes, not for daily business operations. They support decision making at a tactical and strategical level of a business. Their data can come from within an organization or be acquired from outside sources. OLAP databases are typically non-normalized as they don't have many write or delete operations. Their queries are more complex and they are usually populated all at once with existing data. Updates to OLAP databases might occur weekly or monthly, depending on the business's sizes. These databases are often very large, such as data warehouse and data marts, which follow the OLAP schema. We will touch OLAP databases briefly in the later chapters. On this slide, you can see a general approach to a data management. Typically, data is stored within a database management system or DBMS. In the diagram, the data is shown in different boxes to help illustrate the concept, but usually it all resides in the DBMS. These database management systems interact with some type of applications, often referred to as the front end. If you have heard the terms front end or back end, here is how they relate. The back end refers to the database management systems where the data is stored and managed. The front end is the applications that user interact with, like a website or a software interface. For example, when you visit a website to buy something or search a catalog, you are using a front end application. This application communication with database management systems in the background to retrieve the data you need. As a user, you don't interact directly with the DBMS. Instead, the application does that for you. Most database management systems don't come within built-in applications, so developers create them using techniques like PHP or .NET. However, there are some databases applications like Microsoft Access that allow you to develop the front-end application using the same technology as the DBMS. On this slide, you can see the process of the create a OLAP databases. OLAP databases are typically created from transactional system, also known as a OLTP. We start with internal transactional and relational databases, which are the source of data. There might also be some external data involved. This data goes through the process called extract, transform, and load, or ETL for short. During ETL, the data is processed and then stored in data warehouses and data marts. These data warehouses and data marts are example of the OLAP or online analytical processing databases. The databases on the left side of the slide are usually OLTP or online transactional processing databases. OLTP systems handle a day-to-day transaction and operations of a business. In summary, OLTP deals with the everyday activities of a business, while OLAP or OALAP is focused on analytical processing for decision making. At the end of this course, let's talk about the databases skills and careers you can pursue. One of the most valuable skills in any businesses with a computerized database is SQL query skills. SQL or sequential query languages is the language we use to ask questions and find answer from a database. Every business, whether in the private or public sector, needs people who can run SQL queries to ask and answer important business questions. Knowing how to use SQL is a significant advantage and a great skill to highlight on your resume and LinkedIn profile. Next, there are SQL database administration skills, which you will also learn the basis of it in this course. As the database administrator, you will learn how to create and maintain databases, set up tables and their relationships, create views, connect databases to the different applications, and ensure data integrity and security. Database administration require more technical skill than SQL querying. While there are fewer jobs in this area, they tend to pay more. In this course, we will focus more on the SQL query skills, but you will also get some experience with the database administration. Okay, so that was the overview of the chapter one, covering the importance of the data and databases, as well as the architecture and structure of the database management systems and their different types. Again, to do well on your quizzes, exams, and assignments, you need to make sure to read the chapter one completely and check out the other resources available in D12 module for this chapter. If you have any question, feel free to email me using the preferred communication method mentioned in the syllabus. Thank you so much.